Alright guys, welcome to lesson 8.6. Today we're going to talk about something called the compound interest formula. That's a formula that's used in finances, so that's what we'll be chatting about today. So what is interest then exactly? Well, as you guys know, sometimes we need money, and sometimes we don't have that money that we need, and so what we do is we borrow it from somebody, right? And sometimes people are just kind. If you borrow it from your mom or your brother or sister, they might just loan it to you, and they just expect you to pay it back later, right? But in the world of business, whenever you borrow money from somebody, they say, that's cool, you can borrow money from me, but when you pay me back, you're going to owe me a little bit of extra money because I am technically giving you a service, and you have to pay me for my service. And that extra amount that they're asking for is the interest. And usually they do it in terms of percentages, right? So they say, okay, yes, you can borrow money from me, but when you pay it back, just throw on a 5% of how much you owed. So, if you borrowed $100 from them, when you pay them back, you'll give them the $100 plus an additional 5% of 100. And so you guys know now how to find a percentage. 5% is 0.05 times 100 would be $5. So basically, here's the fee they're charging you to loan you the money. So they're giving you $100, and then they're going to charge you an additional $5 for the service. And so since you had to borrow money, when you pay them back, you're not going to pay them back just $100, you're going to pay them back $105. And that's what we call interest, is whenever you owe somebody some money like that. So now we're going to learn about something else, though. I'm sure many of you guys already knew that. We're going to about a special kind of interest called compounded interest. And that's where exponential functions come into play, which is what we're learning about in this unit right now. So suppose that you wanted to invest $1,000 into a bank, and that you have 3 banks to choose from. All 3 banks give you the same interest rate. They're all willing to give you 20% interest per year. Now, just so you guys know, that's extremely unrealistic. No bank would ever do that. But let's just say that it's a super generous bank, and they're willing to give you 20% interest per year. But all 3 of these banks do it in a little bit of a different way. And the question is, which one turns out to be a better deal for you? So one bank is willing to give you 20% of what you put into their bank one time. The other bank feels, I'm not going to do that. What I'll do is I'll give you 10% in the middle of the year, and then I'll give you the other 10% at the end of the year, and that makes a total of 20% altogether. And then finally, the third bank says, what we're going to do is we're going to break the year up into 4 quarters. In the first quarter, we'll give you 5%, in the next quarter 5%, in the next quarter 5%, in the next quarter 5%. And if you do 5% 4 times, that's still 20%, right? So then you might think, well, they all sound the same, but you'll actually see they're not. So let's go ahead and take a look. So let's take a look at Bank 1. You're putting $1,000 into their bank, right? Now after 1 year goes by, you've still got your $1,000 after that 1 year. It's in the bank, right? It's not going anywhere. But they promised they would give you an additional 20%, 0.20 of 1,000. Okay, now that actually turns out to be $200. And so at the end of the year, you're making money. You just made $200 for letting that bank have your money. So these guys promised to give you 20% once at the end of the year. Okay, so let's go ahead and take a look at bank number 2. So for bank 2, you're going to invest $1,000, right? And after half of a year goes by, not the full year, but half a year, they're going to give you 10%. So that's going to be $1,000 plus 10% of $1,000. Now, that would be 1,000 plus 100, which is 1,100, right? Now another half year goes by. And after that half year, you've still got your 1,100, but they're going to give you another 10%. But do you guys notice something different this time? Instead of taking 10% of 1,000, they're taking now 10% of 1,100. Okay, and that happens to be $110. Okay, and so when we add these together, we end up with $1,210. Interesting. So even though this bank over here, Bank 1, gave you 20% once, and these guys gave you 10% twice, it turns out that this bank number 2 here is willing to give you more money, actually. Not much more, but a little bit more. As you can see, they're willing to give you an additional $210, whereas Bank 1 is only willing to give you 1. So that's interesting. So assuming that this pattern holds, we would expect that the more times they break the 20% up, the more money we're going to be making. So I predict now, seeing that breaking it up into 2 pieces gives you more money than just once, I predict that breaking it up into 4 pieces will give us even more money. So let's go ahead and do that really quick. So once again, we start off with $1,000, right? And then, but they're breaking the year up into 4 quarters. And so after the first quarter goes by, they're willing to give us 5%. And there it is. And then the second quarter goes by. So now but before I do that, after quarter 1, now we're up to $1,050. Then another quarter goes by, and they give us another 5%. 5% of 1,050 added to 1,050 gives me this. And then in the third quarter, we're at 1,157. And then finally at the fourth quarter, we're at 1,215.51. And so all that to say, we are now at the final amount. And so there you have it. So the more times they're willing to break up their annual interest rate for you throughout the year, the more money you'll make. And that's what we call compounded interest. The number of times it's broken up is what we call compounded. This one's compounded once, this one's compounded twice, and this one's compounded 4 times or quarterly. And that's what we call compound interest. And the more compounded it is, the more money you'll make. Now, you notice it's not a huge difference, but hey, it's a difference, right? So it makes a little bit of difference. Now, the next thing I want to show you guys is a faster and exponential way to get these answers, okay? So let's go ahead and see if we can figure it out. We know from here that we get 1,200 and forgot it. Let me rewrite. So how do we get here a little bit more quickly instead of having to do it over and over and over again? Well, basically what we're doing is every time we're taking 5%, and we're doing that 4 times, okay? Now, question 1, where did the 5% come from? Well, it comes from taking your total interest rate, as a decimal, of course, and dividing it by 4. And that's where the 0.05 comes from, right? And that is my interest rate that I'm adding to the 100. So here's our original formula. You guys remember this? So we have y equals a, parentheses 1 plus, and there's my percentage. And then this is however many times we're going to do it. Well, we ended up doing it 4 times, right? So there's that. And my starting amount for this particular problem was $1,000. So I'm just going to go and put the 1,000 here. So I'm going to show you guys we can actually just do this instead. 1,000 times 1.05 to the 4th power. If you do that, you're going to get that answer, and you're going to get a lot more quickly. So instead of taking 5% 4 times and adding it on, we can just do 5% as our R value and add it into our growth rate. And so that is a much faster way of getting it. So now we're ready to actually introduce you guys to the compound interest formula, okay? So the compound interest formula looks like this. It's y equals your starting amount, which is A, parentheses, 1 plus the interest rate, but divided by however many times you want to split it up in the year. And however many times you do that in the year, that's how many times you're multiplying that growth factor. Now, to add an extra little twist to it, what if we wanted to look at 2 years or 3 years or 4 years and not just 1 year? Well, then you would just multiply that in by however many years you want to do it by. And this is what we call the compound interest formula. Okay. Now, personally, I like to look at it like this, but the most common way that this formula is given is with some slightly different letters, and I'll show you. They usually write it like this in textbooks, and I'll tell you why. Instead of Y here, they put a big A, and instead of a little a here, they put a big P. That's the only difference. They mean the same things. This still means the starting amount. I don't know why they choose to use A. I think that's confusing. There's probably a reason, but I don't know it. Anyway, the reason they choose to use P, though, I know that, because in the world of interest, the starting amount is what they call the principal amount. It means the starting amount. So whether you're looking at the formula like this or like this, it's the same thing. You have the final amount is equal to the starting amount multiplied by this growth factor raised to this power, where R represents your growth rate for the whole year, N represents how many pieces you're breaking it up into, and T represents for how many years you want this to be going on for. And so that is our compound interest formula. So let's go ahead and summarize that. There it is. And here's a summary of all the different pieces. Okay? All right, that being said, we're ready to jump into some examples. All right, so for example 1, you're going to want to transition to this other sheet that I attached to our notes for this assignment. And let's go ahead and start with number 1 as our example number 1. I'm going to do 2 examples, let you guys do 2 student practices for this first set. So we want to recall that our compound interest formula looks something like this. Okay, and it's important to remember what those letters represent. This number here in this problem is the starting amount. Jack invested $5,967 into a retirement account with a fixed annual interest rate of 4%. That's going to be our R value. It's being compounded 4 times. That's our N value. So R is the percentage. How often is compounded is the value of N. Question is, what will the balance of the account be after 19 years? And that's how many years we're going to be doing this for. So basically, you just have to figure out what variable each number corresponds to and then plug it in. So A is equal to $5,967 plus my annual interest rate of 4%. Now, the trick here is with this guy, you're going to need to transform it into a decimal. And you guys don't remember how to do that. You just take 4 and divide it by 100, and that's how you get that. So that's what you're going to put here is the decimal version of that percentage. The N value is 4. And then up here we have N times T, and T is 19. And there it is. Okay. So let's go ahead and see how do we simplify this now in a calculator so we can get a final answer. So I'm going to show you guys 2 ways to do this. One way, the first way I'm going to show you just by typing it all in at once. Now, if you're going to be typing it all in at once, here's how we're going to be doing it. We'll make a few modifications to this whole expression here. I'm going to be putting this piece in parentheses. And the power, as you guys have seen in other lessons from this unit, the power button looks like a little arrow. Now, since we have 2 things here in the power spot, we do need to put that in parentheses also. So this is exactly how I'm going to type it into my calculator. So it's going to be 5967 parentheses, 1 plus, and then another parenthesis. Oops, I did too many there, so I'm going to back up and delete that. Another parenthesis, 0.04 divided by 4, close parenthesis, that's the red one, and then another parenthesis, the black one, and then we have our power button, and then in parentheses I'm going to put 4 times 19, and then enter. And there's my final answer. So my final answer would be $12,711. Okay. Now, what some of you guys don't have a calculator that would allow you to type all this in at once like that, and so you're going to have to do it in pieces. All right. So let's go ahead and see how to do that in pieces. And if you do have a calculator that does this, then you can kind of skip through this next part because you don't need to see it. Okay, so if you're going to be doing this in pieces, the first thing you're going to want to do is this piece right here, 0.04 divided by 4. So 0.04 divided by 4. And it's 0.01. So what I'm going to do is I'm going to replace this now with 0.01. And all I'm doing, you guys, at this point is order of operations, PEMDAS. I'm going to simplify what's inside the parentheses first. But just to walk you through that, that's what we're doing. All right, so the next thing that we're going to do is I'm going to add 1 plus the 0.01. Now, honestly, we could just do that mentally. 1 plus 0.01 is just 1.01. That's not too hard. You could do it on a calculator if you need to, but it's just 1.01. All right, the next thing I would do is I would simplify this. 4 times 19. And that's 76. So let's go ahead and replace that with just 76. All right. Next thing that we're going to do is so after you do your parentheses, you're going to do your exponents. So 1.01 to the 76th power. Okay, so let's do that. There's that. So therefore I can go through and erase this whole thing here, because I now know what that equals. That whole thing there happens to equal 2.13. And the more numbers you give, the better, because it'll be more precise that way. And then finally, we're going to multiply these two things together. So it's going to be 5967 times 2.13021. And we should have about the same answer as I got doing it the other way. Now, just so you guys know, for the remainder of our work today, I'm not going to be doing it the piece by piece way. It takes too long. But you're welcome to use that method if you need to. But the calculators that you'll have access to during the test, if you don't have your own, will work the fast way that I showed you. So let's go ahead and move on to a second example just to kind of really get it cemented into our mind. So this time I would encourage you guys to kind of think in advance right now. See if you can find your A, your R, and your N, and your T. So pause the video here and see if you could properly label those. So there's the proper identification of the variables. Now the next thing I want you to do is see if you could put it into the formula appropriately. So pause the video here and see if you guys can appropriately place it into the formula. All right, and so that's what that would look like. Last step is to go ahead and see if you guys can appropriately work this out. Once again, if you can do it the piece by piece way, or you can do it the way that I showed you. It's a little bit faster by typing it in all at once. Your call. But go ahead and work it out on your calculator and see what you guys get. And that's what you should have gotten. And so what does all this mean? This means that if this person invested $2,814 into a savings account, and that bank told them they would give her 5% additional 3 times a year, after 6 years, her amount that's in the bank would have gone up from that to that. It's pretty good. All right. So I'm going to have you guys do the next two problems, numbers 3 and 4. So go ahead and pause the video here. Try these two problems. When you unpause the video, you will see the solution. All right, and there you guys have it. Those are the solutions. I'll let you guys look that over and study it. If you need to look a little longer, go ahead and pause it, because I'm going to go ahead and move on to the next part of our lesson. All right, so let's go ahead and do number 5 here. I'm going to call this example 2 because it's a new type of problem. You'll see why in a moment. So it says, I don't know how to say that name, Mei invests $2,690 into a retirement account with a fixed annual interest rate of this compounded 2 times a year. After 15 years, the balance reaches that much. So this is interesting because they're giving us different information. This is the starting amount, so we'll call that P. This is the N value. This is the T value. But what's this guy? Well, that's actually the final amount, which letter is A in our formula. So what's interesting about this is that they gave us the A this time, and they didn't give us the R. There's no R value. And so that's what they want us to find, is they want to know what is the R value. And that's what we're going to try to find. So let's go ahead and set this up and see what that looks like. So we're going to take our compound interest formula, which looks like this, right? And just so you know, that's an R, it's not an N. The A value, we know this time, it's $7,550.28. The P value, we also know, it's 2,690. What I don't know this time is I don't know the R value, so I'm going to leave that as an R. But I do know the N value is 2. It's compounded twice a year. And I also know how many years have gone by. Okay, so you're going to need your calculator for this kind of stuff. First of all, let's go ahead and multiply this together, 2 times 15. By doing that, we're going to end up with 30. So my goal here is I want to get R by itself. So the first thing I'm going to do is I'm going to divide both sides by the P value. Divide by the P value. So we want to get rid of that first. And let's see what that gives us. So, of course, on the right side now, we're just have this. There's no more P value because we got rid of it. And for the left side, we're going to need a calculator. And we're going to have to round it because it's a pretty long decimal number. But let's give it at least 3 decimal numbers, I guess. That's probably good enough. 8, 0. And if I round to the 3rd place, I'm going to call that a 7. So there's that. All right. Now what do I do? The next thing I want to do is I want to get rid of this 30. And what we're going to do is we're going to do something kind of odd. But we've done it before, I think, in this class, if I'm not mistaken. We're going to raise this side to the reciprocal power. Why? Because when I do that, you would multiply these. And when you multiply a number by its reciprocal, they cancel out. And I'm allowed to do that so long as I also do it to this side. So I'm going to raise this side to the 1 over 30 power. Now for that, you're going to need your calculator. Okay. On the right side, I have now 1 plus R over 2. I don't really need the parentheses anymore because there's no more power on the right side. But on this left side, we're going to need our calculator. So how do I do this on my calculator? What you're going to do is you're going to type in your number, 2807. You're going to find your power button. And then in parentheses, you're going to push 1 over 30. Make sure you use parentheses. Okay? So let's see what that comes out to be. And for that, we get 1.035. All right, what's the next thing we're going to do? The next thing we're going to do is we're going to minus this 1 on both sides. So this one goes away, and this one goes away, and we're left with 0.035 is equal to R over 2. The last thing we need to do is just multiply both sides by 2. So multiply this side by 2, that cancels those out. Multiply the other side by 2, and I'm going to end up with 0.07. Now that's my interest rate. Now you can leave your answer like that. There's nothing wrong with that. But as a percentage, if you wanted to find that as a percentage, you could just multiply it by 100, and that would be 7%. would be the interest rate. So either one of these answers is acceptable. But there it is. So for this particular problem, they did not tell us the R value, but they told us the final amount. And these are the steps that you would go through. Okay? Let's take a look at another type of problem where they give you the A value again, but they're going to ask us to find something else that's a little bit different this time. So this one says Daryl invests a sum of money in a savings account with a fixed annual interest rate of 4%. So there's our R value. R is equal to 0.04. If you divide 4 by 100, you'll get 0.04. Compounded 4 times. Well, there's our N value. After 12 years, there's our T value. The balance is this. Now we have to be careful here. Is this my starting amount of money or my final amount of money? Well, this is what we have after 12 years. This is my final amount of money. So this is an A value. So you'll notice we have our R, we have our N, we have our T, we have our A. What we don't have this time is the P value. So here's our formula for compound interest. We're just going to plug in everything that we do have so that we can solve for the pieces that we don't have. I don't know what P is, so I'm going to leave that just as the letter P. My R value is 0.04. My N is 4. And my T is 12. So how are we going to do this one? All right, well, you could put this entire expression in your calculator if you wanted to. You could do parentheses 1 plus parentheses 0.04 over 4 raised to the power of 4 times 12, all in parentheses. You could do it all at once, or you could just do it in pieces. It's up to you. I'm going to go ahead and just, a lot of this I could just do in my head. I know that 0.04 divided by 4 is going to be 0.01. And if I add 1 to that, I get 1.01. And this is 48. And then we're going to do this on our calculator. Let me see what that would be. Before I do that, let me put down the final amount here also. I want to keep bringing that down with us as we go. All right, so doing this on my calculator, I end up with 1.612. Last thing I need to do to solve for P is just divide both sides by 1.612. Those will cancel that way. And our P value turns out to be, once again, we'll use our calculator there, 6974. 0.9, I'll put it up here, 94 would be my decimal amount. All right, so $6,974.94 would be the final answer there. So that's how much the starting amount was. All right, so in other words, when you're doing this compound interest formula, you're not always looking for A. You might be looking for P, or you might be looking for R. At this time, I won't be asking you guys to find N or T. To do that, you need to use something called logarithms, which we're not quite ready for yet this year, so we'll hold off on that. But for now, you may be asked to find A, you may be asked to find P, or you may be asked to find R. So let's go ahead and throw at you guys the last two problems. Your job is to fill in your formula, identify which one you're trying to find, and solve for that variable. Okay, so go ahead and pause the video here and try this last student practice number 2. And when you unpause it, you will see the solutions. All right, so here are the setups and solutions. For number 7, we did not have our P value given, and so you would follow the steps that I did on example 6 to find out that P equals 4526. On number 8, we are not given the R value,
And so you would follow the steps that I gave you on number 5 to determine that R should come out to be 0.07. Right, and so that'll do it for our compound interest formula questions for the day, and hopefully that was helpful, and we'll see you guys in class.